If you don't want to waste time guessing how to integrate Python machine learning with Android devices, this video may be for you. We will implement a simple machine learning algorithm in Python and show a method to access the output of that machine learning in Android environment. We have some raw data on YouTubers' estimated daily income for average viewer engagement rates. This data is for a certain level of daily video views. We're going to implement a linear regression model that trains on this data and roughly estimates the daily earning for a given viewer engagement percent. In this video, we are keeping the machine learning model deliberately simple so that we can focus on the Android Python integration for machine learning rather than deal with the complexity of an accurate machine learning model. So to create the linear regression program, we will be heading over to the backend, the server backend where our Flask-based website is already deployed. I have a very basic website here, which is hosted on pythonanywhere.com, and the Python script here, myapp.py, has the very basic URL definitions in it. I'm going to add my Python code for our simple one variable linear regression to this. We want to connect the linear regression as an example of machine learning and integrate that with the front end, which is based on Android and Java. So just to recap, we have Python in the back end, which is where we will implement the machine learning algorithm. The machine learning functionality there is linear regression with single variable, and then we will integrate this with the Android front end, which is an app that is powered by Java on Android, and that app will obviously be deployed to an Android handheld device, which will then access the machine learning program from the backend at pythonanywhere.com. So off we go to the first steps, which would be to import the necessary libraries to implement linear regression. I'm going to import sklearn. So it should be basically from sklearn import linear model and for our data structure needs and loading from CSV files. We're going to depend on the data frame functionality. So I'm going to import pandas as PD. So our basic linear regression should be able to implement a model with just these two imports. Let's head to a new function definition in our Flask Python script in the backend, that is the server side. We're going to give it a URL path, let's say linreg for linear regression, and what this will translate to would be my base URL, which is laptopml.pythonanywhere.com/linreg right here. Now obviously this will not work right now because there is nothing implemented for that URL resource path, but come back to it once we have implemented the backend. So back to our console. Now I'm going to define the function name. I'm just going to call it linear regression underscore single var. So we have one target variable and one independent variable. So let's define a data frame to load data from CSV file. Now I'm going to create the folder and upload there the CSV file with the raw data from which we are going to train our linear regression. To create a folder, let's exit out of the editor. And so this is a working directory. My site is the base directory for our website. And I'm just going to create a directory by name uploads folder. And so that directory is now created. With that done, I'm going to go back to my Flask Python script here. And I'm just going to type in the full path and the file name to read the raw data. And we haven't yet uploaded the CSV file. If we go back to the console here, Python Anywhere console, go to our website base directory, and then head to the uploads folder. We need to upload the CSV file with the raw data here. And that file is right here. This is the data with a pair of variables. The independent variable is the average percentage viewer engagement for a given YouTube channel, and the target variable is an estimated earning at that viewer engagement level. So I'm going to upload this file to my website, and right now I have uploaded the file, and the file name is youtubers_income.csv. So I'm just going to say youtubersincome.csv. So this takes care of loading the file, the data from the file, into a data frame. Next, I'm going to name some columns. Because the raw data doesn't define column names, this is easy to do. So the first column, which is the independent variable, is the average engagement, and the target variable is earnings per day. Okay, so engagement maps to the first column here, and earnings per day maps to the second column here. The way sklearn linear regression is going to work is that it's going to accept two sets of values. One would be an array of independent values of average viewer engagement, and the other would be the array of values for the target variable, which is the earnings per day. So just because the linear regression fit method accepts each of these two sets of data as two-dimensional arrays, I'm going to have to define a new data frame with the array of independent values, that is average viewer engagement, by dropping the earnings per day values from the data frame. So the new data frame only has the values for the independent variable. I'm indicating the axis to give a hint to the drop method that I want to identify the column by name earnings per day, the values for which need to be dropped from that data frame. So now we have a new data frame minus the target variable values df_engagement. We have two data frames. Each data frame is a two-dimensional object. And now I'm going to initiate the linear regression model. So that's our implementation from sklearn. And then I'm going to fit model with the two data frames consisting of the independent values and those for the target variable df_engagement dot values, and then the original data frame minus what's left over after removing the earnings per day values. Train the model to the data set that we supplied to it. Now we should be able to predict the earnings per day based on a value for the independent variable which we supply, which is the average viewer engagement percent. So let's say we select a value of an average viewer engagement of 27.4%. Let's see what the prediction looks like for the average earnings per day for that engagement. And it turns out that the values that the predict function will accept have to be in a two-dimensional array. So I'm just going to supply a two-dimensional array. Let's look at the predicted earning per day for that average engagement of 27.4%. So basically we find out the predicted value. We also print the model coefficient and the model intercept. If you relate this to the simple equation of the straight line, y is equal to mx plus c. M, the slope, corresponds to the coefficient here, and c, the intercept value, corresponds to model.intercept here. So now with that function set up, let's reload the website. You have to reload the website every time you make any changes to the script that powers the website, the Flask Python script. Okay, the reload is complete. So let's look at the website URL that we defined. Remember, the path is defined as linreg, so our base URL is laptopml.pythonanywhere.com and then /linreg. Remember, the URL with this resource path did not work before the implementation, but right now it should work. So there is some error. I have to go look at what the error is. So if we go back to the Python Anywhere console, there are logs. I'm going to head to the error log here and go all the way. Read CSV is not defined. Also, it says home laptopml my site uploads folder youtubers income.csv, no such file or directory. So let's check out whether there is an issue with the file location here. Home laptopml my site. I'm going to copy this and make sure that the path is set correctly. Okay, so here's the issue. I forgot to attribute the read CSV function to the pandas library. So I'm going to have to save this Flask Python script file and rebuild the website because I just made changes to my script. So I head back to the Python Anywhere console and reload our website. And once that is done and come back to the URL, I try to refresh it and it seems like it has worked this time. I can see that it did predict an average earning per day of $37.91 for a supplied value of average engagement level of 27.4%. With the test value of 27.4 working as expected, we now turn to the job of parameterizing the HTTP GET call in the REST API, which is what invokes this function over here. When this URL is invoked, we want to parameterize that GET call so that we don't have to hard code values here. So let's go ahead and code this. In my Flask Python script on the server side, let's access the requests object and place the value in a variable. We call this user supplied average engagement percent. So you're going to name the parameter as avg_eng. That is the parameter that will have to be supplied in the URL when the REST API for HTTP GET is invoked. We'll get to that in a bit. So if the user supplies the parameter avg_eng, then this variable is going to be populated, and so we're going to set prediction equals model.predict, where the independent variable we're supplying to the model is now user_supplied_avg_eng. Else, for the else part, I'm just going to park it at the default value of 27.4. That's just arbitrary. It's got no special meaning here, but we said in the beginning that our code needs to stay simple so that we can focus on the essential and the important aspects. So I'm just going to park it at this arbitrary random value 27.4. And when we do that, we don't need this line over here. So I'm just going to say this would be the prediction for default average viewer engagement percent, 27.4%. And for the user supplied case, I'm just going to add the user supplied value here. That should be it. I'm going to rebuild our website because we made changes to the code. That's done. If you look at not passing any parameter to the GET REST API call, then, oh, something went wrong. I'm going to have to check what that is. Oh, of course. I ended up confusing the format string here, going to escape it. Indentation error on indent does not match any outer indentation level. Okay, I know that. Python is super sensitive to indentation, so this is fair. We need a little bit of a realignment. I'm going to try it one more time. Reload the website. Try the default version. Default version works. Try the user supplied version and 72.5, and this time it worked. Prediction for user supplied average engagement percent. I missed a percent symbol here. Should be 72.5%, is $116.14. So with that, we have a working REST API with machine learning implemented for a basic linear regression with one parameter. Let's head to the integration aspect.